Hey, welcome. Here's your 3 peer instruction questions for the day. So go ahead and take a look at these, and then we'll go on to the next slide and walk through them, but try to figure them out yourself first. So as we look at the first one here, we have an angle in between two sides. The easiest way to see that is to actually go ahead and graph this. Remembering your capital angle represents, or capital letter represents an angle, your lowercase letters represent sides opposite those angles. So we have lowercase a opposite angle A, lowercase c opposite angle C. And then we have an angle in between our two sides. When you have an angle in between your two known sides, you can use this formula right here to be able to figure out the area of your triangle. So we'll go 1/2. Now which adjacent side we put first here doesn't make a difference. Put in our other adjacent side. The reason it doesn't make a difference is because we're multiplying, and you can multiply in any order you want. And then we go the sine of our angle. And then all we have to do is type it into our calculator, making sure our calculator is in the degree mode, and we get our answer. In this case, we had units for our length, so we want to make sure we have appropriate units for our area. Now, the next problem down, we are given an angle, another angle, and a side. And our sides in between the two angles that we have. That's referred to as a side, or not a side, angle, side, angle. If it's any of the ways that we prove triangles congruent back in geometry, if a side, angle, side, an angle, angle, side, 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 or in this case of an angle, side, angle, those always prove triangles congruent, meaning there's only one option for your triangle. So we don't have to be concerned about having two triangles formed in this situation because it's a congruency theorem from geometry, which is only one triangle. We cannot use law of sines initially here because we do not have an opposite pair. We don't know an angle and the side opposite. So here we have our 20, but we don't know the side opposite of A. Or here we have our angle of 63 degrees, but we don't have the side opposite. However, if you know two triangles of an triangle, you can figure out the third one. So you know all your angles add up to 180, so go 180 minus the two angles you know, and we end up getting 97. So we know our third angle is 97. We now have an opposite pair of our angle and its side, so we can now use law of sines. So I'm going to take that opposite pair, and typically I like to have what I'm looking for on top. I'm going to go ahead and try to find B, side B. So I'm going to put my sides on top. So I'm going to put the 16 over B, or 16 on top and B on top. Then I need to go on the bottom, put the sine of the angle opposite the 16, so sine of the 97, over the sine of the angle opposite of B, which is your 63. Now all we have to do is get B by itself, so that means we have to undo the dividing by sine of 63, so that means we have to multiply by it. This is our calculator ready form. All we have to do now is type it into our handy dandy calculator and we get our decimal approximation. We pretty much have to do the exact same thing, but for side A. So we're going to still go what we were given initially here, the 16 over the sine of 97, equals our A, which we're looking for, over the sine of the angle opposite that, which is our 20. Multiply both sides by the sine of 20. It's our calculator ready form. Type it into our calculator and we get our answer. Then we'll move on down to this one here. So in this situation, we have, if we graph this, an angle, a side opposite that, and a side next to that, which is a side-side angle situation. Whenever you have a side-side angle situation, you have to be concerned about how many triangles it's going to form. So, looking at this here, The easiest one to look at is to say, is our opposite side of our angle greater than our adjacent? Well, our opposite side's 190. It's obviously not greater than the 200. So we know it's not this one here. The top one and the third one, both are dealing with the opposite and having adjacent side of the angle on the other side. So let's take our opposite side, equaling to our adjacent side, sine of our angle, and then all we have to do is go ahead and type the right side into our calculator. When we do that, we get 157.6. So it's obviously not the top one. They're obviously not equal. Well, the opposite side of the 190 is obviously not less than the 157, so it's not this. So it's none of these three. Therefore, we know it's the bottom one of two triangles. So how do we go about solving a two triangle situation? Well, you're going to start off solving it just like you would normally. We could use law of sines here because we have an opposite pair, our angle of 52 and our side of 190. So we could take that opposite pair and we could go ahead then and find angle B. We can't do anything for the C's because we don't know either one of the C's. So the only thing we can do is find angle B. I like to have what I'm looking for on top, so I'm going to go the sine of B on top over the side opposite of B, equaling to that opposite pair, the sine of my angle of 52 over the opposite of 190. Now I have to go ahead and try to solve it for B. So that means I need to undo the dividing by 200, multiply by it instead. And then I have to undo my sign. To get rid of my sign, that's that sine inverse. So now I have my calculator ready for 'em. Type it into my handy dandy calculator, and I get 56.05. That's what B is. Oh, well, gee, if I know these two angles here, I could easily get angle C because I know that all my angles in a triangle add up to 180. So go 180 minus the two angles that I know, and I get angle C to be 71.95. Once I know what this angle is, I can use then law of sines to figure out that opposite side. So looking for a side, I want my sides on top. I'm going to take what I knew, the 190 over the sine of 52, equaling that C that I'm looking for over the sine of angle C, which I said was 56.05. Then I have to get C by itself, so I have to undo dividing by the sine of 56.05, so multiply by it. Calculator ready form, and I type it into my calculator. So for the first situation, I solved it. I now have my B, my C, and my angle C. Well, what do you do, though, for that second triangle? Well, this is what the first triangle looked like, because all the angles were acute, meaning less than 90. In a two triangle situation, you're going to have an acute triangle like this, and then you're going to have an obtuse triangle. Well, that's if I can talk here. Sorry about that, guys and gals. What we want to do is to figure out this angle B first here. Our new angle B that we have right here, that we need to figure out, is always supplementary to that first angle we figured out. We figured out angle B to begin with. So this angle B is supplementary. Remember, supplementary means they add up to 180. So to figure that out, all we have to do is subtract it from 180. And we get this. Now, if we know angle A and angle B, we could easily get angle C because all the angles in a triangle add up to 180. So we take our 180 minus our 52 minus our new angle B for the second triangle, and we type it in and we get 4.05. Well, now that I know this angle C, I can now figure out side C. So to figure out side C, I'm going to go what I'm looking for, side C over the sine of my angle opposite, equaling that opposite pair that I was given, my side of 190 over the sine of that 52. Get C by itself, so I got to undo the dividing by sine of 4.05, so multiply both sides by it, and type it in, and I get my calculator ready for them with my decimal approximation. So that's how you do these peer instruction